welcome once again. Right, in previous video we learned the first principle exactly, right, and how to find the derivative of the first principle, and we did a small example also there. Right, now I'm going to find out the another derivative from the another problem. Here is given the find the derivative of the function f of x to the power minus 3 by 2 by the first principle method. Right, now we're going to find the derivative of this. So here our function is here f of x equals to x to the power minus 3 by 2, right? And I'm going to add a small change, right? A very small fraction of the x, a very small change in x, right? That's h. Somewhere in the book you may see as a delta x. So either you're writing h or delta x, both have the same meaning, right? So I'm writing here now h. So it will be now x plus h whole to the power minus 3 by 2. And from the definition of the derivative, what we had learned, that derivative of any function f of x is equals to limit when h tends to 0 f of x plus h minus fx, right, whole divided by h. And finding the derivative by using this this expression, also this formula or the definition of the derivative, is called exactly the first principle, right? If you find the derivative of any function by using this definition of the derivative, that process is called the first principle. So now by the same process we're going to find out the derivative of this function. So that's why now derivative f of x, or somewhere you may see like dy by dx, right, is the same meaning, right, is now equals to limit h tends to 0, right? And now here f of x plus h is here x plus h whole to the power minus 3 by 2, right? X plus h minus 3 by 2, and again minus fx is equals to x to the power minus 3 by 2. So minus x to the power minus 3 by 2, right? And then this whole divided by h, right? So now in next step, how can we solve this? We cannot solve this, right, easily. So what we have to do, I'm doing a small thing here. See, I'm just adding x, and again if I will add anything over here, then I must have to subtract the same thing, right? Then it will have the same meaning. It means simply I mean to say, if there was h equals to something, suppose some 5 was there, right? And in 5, if you add the 4 and again if you subtract the 4, you will get again 5, right? 5 4 9 minus 4, that is 5. So means adding and subtracting something, the same thing from a particular some particular thing, right, is the same meaning, right? Now here suppose it was 10 and I'm subtracting 2 and again I'm going to add 2, then it will not change the value, it will be the same thing. So I added here x and I subtracted also here x. By doing so, what I'm getting exactly, let me show you here. Now I'm forming some standard form, some standard result, right, that we had used in limit chapter, and that is exactly, let me show you here. In limit chapter, what we have learned, the limit when x tends to 0 x to the power m minus a to the power m whole divided by x minus x to the power n a to the power n is equals to, right, is equals to m by n a to the power m minus n. This formula we had learned there, right, in limit chapter. So the same thing, this standard result I'm going to use over here. So when I will use this standard result, so my my limit will be my derivative will be now m by n. This here minus 3 by 2 will walk as a m, right? And here nothing is there, 1 will be walking here, right? If there is nothing, then 1 will walk this 1. If something don't have anything, suppose there is 2, it means power 1, there is also power 1, right? So there is power 1, so this will walk as a n. So m by n, right? So minus 3 by 2 m divided by n, right? And here is 1, right? Here is 1 times a to the power, right? See, x minus a, so the x to the power, that is a to the power x to the power m minus n, that is m minus 1, right? So now I'm just going to solve this, right? So minus 3 by 2 upon 1 is just minus 3 upon 2 times x to the power minus 3 by 2. If there is nothing, then again there is 1, right? So when I will take the LCM of these two, it will be here 2, right? And then 2 ones are, so it will be minus 3, and 1 twos are, so it will be minus 2. So what I'm going to get, minus 3 by 2 times x to the power minus 3 minus 2, that is minus 5 by 2, right? So we can further do also, or you can stop it here also. So what we get here, our derivative is equals to minus 3 by 2 x to the power minus 5 by 2, right? If you want to go further more, then you can also write minus 3 by 2, right? And by going downstairs it will be 5 by 2, now positive. And if you want to go further more, then it will be minus 3 by 2, right? 1 upon root x to the power 5. So whatever you like, right? That you can do by any method. So this is the derivative, right? Or you can simply write dy by dx also, right? So we get the derivative this, right? So like this, by using the first principle, we have to find out the derivative of any function. We don't have to do anything, right? Simply just add a small fraction, means a small change in x, that's h, or delta x, as a supposing as a delta x also you can do, right? And just go and solve and use all the theorems that we have up to this point we have learned, right? Use all the concepts of limit also, and the derivative concepts, derivative formula, use these all things, and you can easily solve this, right? So I hope you now learn the first principle method, and after learning first principle, now we'll be learning some more concepts of principle, some small tricks, right? To find out the derivative, right? There are lots of some rules, quotient rules, right? There are many rules, right? So we'll be talking about that in next video. So we'll be meeting in next video. Bye bye.